Um, so that's me and that's who I work for. And we're also hiring, but with a little plug there. Yeah, so Jamie asked me to come and do a little introduction for 20 minutes on Facebook React. We've been using it aggressively for 8-9 months, quite young still, right? And we also started a React meetup because there wasn't one. So we've had 2 of those, and the third one's next week. You're welcome to come too. So I just thought that I'll just give you like a brief overview, like 20,000 feet. We'll dive in a bit. There's actually nothing to it, so it's a really easy thing to learn. You can learn it in 3 hours, I think. It's not like Angular. It takes you 3 years and you still haven't got it. Right, so why am I here? Of course, Jamie asked me, but one of my colleagues once said to me that he thought that everybody should learn a new language every year. And even if it's not the language that you end up using or programming it in, it gives you a new way of looking at what you do, and you learn things from that, and you can bring things from that into what you do, and you can, and it doesn't have to be language, it can be frameworks, and there's lots of UI frameworks, and I'm interested to learn about Ember, and I'm sure that, because Ember's like much more sort of full stack than React. React is just sort of like a little bit of it, and so there's lots of unanswered questions that Ember can, so I'm interested in what Ember can do for us as well, and I've heard that there's rumours of how React might help, or something like React might help Ember. So we build our applications from lots and lots of different things, right? These days, loads of different things, like plugging like bits of Lego, like Martin's slide. Whole architectures, whole applications, all built from hundreds of different open source components and modules and things. So we can mix and match, right? We can just use a bit of this and a bit of that. And React is quite good at that in a way, because it's very sort of non-intrusive. I mean, you could just do like a little tiny bit of a web page in React. Or you could do the whole application in it, but it doesn't, and so it's all about putting things together and using the best tools for the job, and working out what how you're going to build it. So I think I think there's some synergies between Ember and React that might actually be useful in the future. I don't know where that's going, but it might. But let's see after the talk, because we'll see. I don't actually know anything about Ember. I mean, I did Knockout for a couple of years. I did Angular for 6 months, and been doing. Well, I did component.js, which isn't really a framework as such, but it's a component-based thing. And let's say we've been doing React for the last 8 months, and but I've never done Ember, so I'm here to learn as well, which is good. But if you fancy coming to the React meetup, it's next Wednesday. End of plug. All right. What is it? So Facebook are quite clever in the saying, that it's a library, not a framework, right? So it's supposed to be very non-intrusive and not get in the way, but it's a bit weird, right? It's a bit out there. So some people call it the V in MVC, but I don't think it's that at all, because MVC, the sorts of applications that we're building at the moment with React, MVC doesn't really play much of a part, to be honest, which is a bit weird. It's out there, right? That's what everyone in the world is doing MVC. We're kind of doing something different. There's already too many UI frameworks, and why do we need another one? But this is kind of a really interesting thing. So this, Martin's talk earlier was all about components and stuff. This absolutely is the future of web development, is component-based development, right? I think we're getting to realise that, and React is all about components. So it's actually quite similar to web components, but it's not anything like them, in the sense that it's something that's you build your applications from component-based hierarchies, exactly the same as web components, but they're not baked into the browser. They're sort of float across top. One of the problems that React addresses is that we think that state is hard to manage, and the applications become really complicated when you've got lots of state in your application. And if you talk to the functional guys, they don't have any state. State's like evil stuff. You know, everything is just what it is. Right? You know what I mean? You get data, and that's what it is, and you know, there's no sort of managing state across an application. And React people say that two-way binding is a little bit too complicated, and in big applications it can get a bit messy when you've got lots of bindings to manage.
Only if you use jQuery.
Only if you use jQuery, yeah. And then this last one, which we'll come back to actually, which has been thrown at me a few times, which is like, don't mix logic and presentation. And they think that React has poor separation of concerns. But I disagree with that, and we'll talk about why in a bit, because there's actually quite good separation of concerns in React, but it's just different, that's all. So it's like, whoa, you know, it's different. It's not like anything, and they say give it 5 minutes. Everybody that I've seen who's given it 5 minutes is actually, whoa, actually, this is different, but I quite like it. It's really, really easy to learn. So I said easy then, and that says simple, and obviously simple is not easy. You know, anything can be easy after you've learned it. But it is generally genuinely simple. And it actually makes building your applications quite simple as well, because the way you think about building your application is very much different. We'll come on to that. There, complex interactions become easy to reason about. So when we look at how it works, we'll see that you get a hierarchy of components, and there's no data binding anywhere near it, and you effectively are recreating your whole application anytime the data changes, which sounds like it would be a performance nightmare and absolutely horrendous in the browser, because we all know that the DOM is really slow. But because all you have to think about when you're building your application is, if the data looks like this, my UI looks like that. That's it. Right, so some really, really complex problems, some really, really difficult things to work out, actually just completely disappear, and it's just, this data says this happens in the UI, and that's it. Really, you know, non-intrusive we talked about. It's actually really fast. So you would think that re-rendering your whole application every time any data changes would be like horrendously slow, and but it's actually not. It's actually incredibly fast. I want to talk about how and why that's fast, and what they've done to make it fast. So this is out there. This post, which I'll put the slides up somewhere, but this post is actually quite cool. Like, why you might not need MVC with React.js. So kind of like it turns everything on its head in a way, in the sense that we're building quite big applications right now without any MVC anywhere near it. Just quite interesting. So to Martin's presentation, which was excellent, I thought. What about web components? Why is React different to web components? It is a component-based thing, right? But this Peter Hunt, who works for Facebook, he has been involved on the React thing for quite a while. They open sourced it 10 months ago. And so it's quite young, but he's been working on the team, and this is what he said. There's a lot of stuff you get for free when you build, like the browser doesn't exist, and this is one thing that distinguishes React from web components and Polymer and that kind of thing. They're getting closer and closer in with the browser, and we're getting farther and farther away from the browser. I think that our technique is more sustainable in the long term. They're quite controversial. But web components are great, right? But you have to have the support or the polyfills, or you're going to struggle on really old browsers. React doesn't almost treats the browser as a rendering engine and nothing else. And when you do that, you can abstract away all the browser differences. So you program with a HTML5 compliant CSS3. Actually, CSS doesn't really come into it. HTML5 event system, regardless of what browser you're using, even if it's IE6. The React sort of kind of puts this layer over the top, which gives you this consistency, so you don't worry so much about differences in the browser. And they can do that because it's moved away from the browser. We'll look at how that happens. It's all down to this thing, the virtual DOM. So the DOM is really expensive to update. It's expensive to update because the browser has to relay out stuff, has to work out, like, can you imagine it, how much computation goes into CSS? It's unreal, probably, I don't know. But I could just, redrawing the page, it doesn't really know what it's got to do when you change stuff, and it's expensive to update, it is. So what they've done is they built this like lightweight DOM representation over the top of the real DOM. So it's actually not over the top of it, it's completely separate. It looks like the real DOM. So there are H1 components and there's div components, and there's a full HTML5 implementation of the DOM, but in real lightweight JavaScript objects. And this is the key to how it works. When you build a component, the simplest component just has one function in it, which is a render function. And that render function takes some data and produces some virtual DOM. So it's pure in the sense that it's idempotent. You can run it as many times as you want. If you throw the same data in, you'll get the same virtual DOM out. And it is literally just a way of translating your model into your view. It's literally, if the data looks like this, this is what UI I want. And it's pure because it doesn't have any side effects, and you can run it as many times as you like, and you'll always get the same output if you put the same input in. If you put different data in, you get different virtual DOM out. That data might have just changed very slightly. So this, when I'm talking about data, I mean, it could be a whole object graph, a whole model of some sort. It could be anything. If it's changed, you get a different virtual DOM output. So this virtual DOM is a representation of what your UI looks like. And then, after it's created this virtual DOM, it runs a diffing algorithm, and it compares the previous virtual DOM, the previous what your application looked like before, with what it looks like now, and it computates the minimum set of real DOM mutations or modifications that it needs to make. So, if in the model you've added an item to a list, and that's an extra li element in a UL, then it would work that it's just got work out that it's got to just add that, or where it's got to add it. And it doesn't re-render any of the rest of the DOM or actually regenerate anything else at all. All it does is make the changes that that are correct for the data, the way the data's changed. And a really interesting side effect from this, which we'll talk about in a second, is that if you do a diff between the new version and the old version, then you get undo. So it's like the reverse set of changes. So if you just literally swap old and new with new and old, you can go backwards in time instead of forwards in time with your UI. So you kind of get undo for free, which we'll look at because it's actually quite interesting. It's a minor point, but it is quite fun. So how does the diffing work? This before and after looks exactly the same, I know. But what it does is it basically goes down each level and says, there's one item there and it's this and it's got this data, or it looks like this, and there's one item. These are virtual DOMs, right? These are not real DOMs. And it just compares them bit by bit. But if I don't know, the text in this span changed, then it would just generate the DOM mutation that needed to do that. So it works with these two things called state and props. And props are the things that are passed down into your component, and they represent the data that your component is rendering. So if you think of just like a div tag, for instance, or a span or something like that, the props would be maybe its ID, its class name, you know, any HTML attributes, right? So props and attributes, same way, they just call them props, properties of your component. But in you know, if you're, because React has a component for every single HTML element, you can interchange the word props and attributes, same thing. They're passed in by the parent component, and class name is a built-in one, and that sets the CSS class, and is expanded might be something that you've invented to see whether it's expanded, you know, to specify whether it's expanded or not. But state is internal to the component, never leaks outside the component, and should be kept to an absolute minimum. And it can't necessarily be managed by a common ancestor. So imagine, so this is what we use state for. We almost never use state. We always pass stuff in through the props, and we'll talk about that in a second. But the state is absolutely minimal. So if you think of like a radio button or something like that, it could be the state could just be managing like which one's selected or something. It's sort of not really related to your model or the wider application thing. It's just sort of like quite self-contained. But if more than one component needs to work with the same state, then it would be stored in a common ancestor. And then these are the methods that you get in your component to handle state. So there's a get initial state, which just returns an object that specifies what the state for that component is. There's a set state, and set state is quite important because that allows you to change the state of the component. Force update will cause your component to re-render, so almost never use it. It's almost unnecessary. Should component render allows you to specify whether, if you know more than React does about whether that component should render, you can return false from that and it won't actually do it. So it's a way of getting even more improvements in efficiency. So set state, if that's your component hierarchy, your sort of virtual DOM on the left-hand side, in every place that you call set state, so if you call set state here, here, and here, it marks those as dirty, and it's only those elements or components, children, that will get rendered. So on the next render pass, only those marked as dirty, or only ones that you've literally called set state on, change. So this is what a React component might look like. This is like hello world example. So there's a render component method which you can render any component with, and you can render that component into this DOM element. So that says render this component called h1 into this DOM element in my page. So this might be the only DOM element there is in my page. And it's an h1 that has no props. This is where the props go in the first argument. So it has no props, so we don't want to pass it a CSS class or anything like that. We don't want to give it an ID. We don't want to do anything. Just want to give it a child. The second and third, etc. arguments are the children of that, and it will actually create a span for us, or whatever it needs to do to. But we could have specified a span if we wanted to. But the problem with building components in JavaScript is that it can get really messy. Get out of hand really quickly. You've got lots of braces and you've got lots of indenting to do, and it can look a little bit messy. Oops, sorry. So they invented this thing called JSX, which is like a JavaScript with some kind of XML-like syntax embedded into it, which allows you to have a more familiar HTML-like approach to writing your components. So that is exactly the same. So JSX itself doesn't do anything. It's just a compile to JavaScript language, just like loads of compile to JavaScript languages. And that h1 literally just becomes react.dom.h1, and it compiles to that. So you can do either, and depends. They think it's great. I'm not so sure. I think it looks a bit weird. And Red Badger were quite big fans of LiveScript, which is sort of bare bones, minimal, well, from a look and feel. So stripped back JavaScript's a bit like CoffeeScript, well, a bit like what CoffeeScript should be, and that's exactly the same. So that's exactly the same code in 3 different ways: JavaScript, JSX, and LiveScript. So you don't need commas where you don't need commas, and it's quite sort of stripped back. But what it does do is it allows you to write components that are actually really readable. So this component is a tab, 2 tabs on a page. This tab is active if the shopping method is delivery, and this tab is active if the shopping method is collection. And it uses React to create a class. The display name is, we'll come on to in a bit, but that actually allows you some really good debugging tools in the browser, so you can see where you are in your application. So this is effectively like in web components, like what goes into the tag itself. What could be called tag name, I guess. We've got some mixins which are just going to give us this translation helper, and there might be a link helper or something in there, I don't know. And it's the simplest form of component. It only has a render method, and all it does is create a UL with class name tags and 2 LIs in it. The first one has a class name of, so left, it will have a class name of left always, and it will have a class name of active if the shopping method is delivery. And then it creates an anchor underneath that with an href in it, which formats the so we pass in a store which has got the data in it, the model and stuff like that, and it's got some helper methods on it as well, so it knows how to format a URL for delivery, and that becomes the href, and then we've got a translation there. So these are the props, and these are the children. Oh, this is the child. We'll just go in as the content of the anchor, and the same thing happens on this side, and that's it. There's no data binding or anything like that. When the data changes, it re-renders the whole thing, rebuilds the whole thing. This is another example, so also in LiveScript. So also a very simple component. It renders a header element with that class name, and then it pulls in another component called cookie policy, which is basically just, typical cookie thing, policy acceptance thing. But it only does that if the configuration says that it needs a cookie policy. And the next, it creates a div. And so this is quite interesting. If the children of the div here will either be, if there's a show cancel, there'll be an anchor in there. Otherwise there won't. This anchor will always be there. That's the second child. So you can see how you can sort of like just create different UI depending on what your data looks like. Life cycle of a component. There's a will mount, a did mount. It will receive new props. Should it update? We talked about. There's a hook before it updates and a hook after it updates and a hook before it unmounts. Almost never need them really. So data flows from parent to child, just like one-way data binding effectively. That could be considered as your one-way data binding. So you just pour data in the top and it just sort of floats down through your component hierarchy. And then if you want to do interactions, you can either, one of the ways of doing it is to pass callbacks down from parent to child, and so that the child can call that callback when something changes. And they can modify the parent state, and that's a bit like two-way data binding. We almost never do that though, because there are better ways of doing it. For instance, there is a synthetic event system, which is like a full implementation of HTML5 events. So you don't have to worry about like old IE event stuff. And that bubbles up, and it's just exactly, a delegated event system that's just all right to use, quite cool. And then there's this thing called Flux, which is like an architectural pattern which Facebook have put on top of React, which is really a simple one-way data flow around your application. So maybe something on the server changes, or some action is dispatched to one or more stores. Those stores do what they want with the data, update the model and stuff, and then they just say, I've changed. And the view will go, okay, I'll redraw, and it redraws. And maybe the user interacts with something in the view, and you can then dispatch another action to the stores, and they will update their data, and they'll go, I've changed. And the view will go, okay, I'll re-render again. And it just goes around and around like that. So it's actually quite similar to game programming in a way. We'll come on to that. But this is typically what Flux actually looks like. That's an oversimplified version. So there might be some web API or whatever, and they create actions when the data changes or whatever. Dispatches through the stores register with a dispatcher and register some callbacks that can be called when specific or when a message is dispatched to the store, the data changes, it will just basically fire an event that allows the view to re-render. It's the same thing and a little bit more complicated. So this guy, Peter Hunt, we talked about, good talk at JSConf EU, and at 20 minutes and 8 seconds into that talk, he talks about this, how React is a little bit like Doom 3 engine in the sense that in the Doom engine, you've got your game state and your sort of like your world, and then some game logic, and then there's an intermediate representation of what the scene should look like, and then there's a rendering engine which spits out stuff to the graphics card. So in a game, right, you've got every pixel on the screen. You have to calculate what the color of every pixel is every single frame, and the color is influenced by all sorts of different things happening, the way the light falls on the scene, how many lights there are, how it reflects off different types of surfaces, all that sort of stuff. Lots of calculations, but it's all done every single frame. Immediate mode programming, right? So it doesn't do anything unless you tell it to do it. And React is a little bit like that in a way, because if you overlay what the React parts look like on the left-hand side, you've got application state and events or whatever, and then you've got React components which generate a virtual DOM, which is like a description of what that scene should look like or what that page should look like. And then it compares that with the previous one, and it computes the minimum amount of stuff, and then just fires them off to the browser. It just literally treats the browser like a rendering engine. So it doesn't actually have to be in a browser. And that's quite interesting, because this could be a string of HTML that comes out of here. So you can do server-side rendering. We'll come on to that. It could be SVG, or it could be a canvas, or anything. It doesn't have to be HTML. It doesn't have to be a DOM. So it's actually just sort of almost like a forward renderer in a game engine, which is quite nice. So isomorphic applications. So we saw a render component earlier. You can render a component and slap it into somewhere in the DOM. Render a component to string, literally just because it's a virtual DOM, right? So you create one virtual DOM on the server, which represents the state of your data, and then you just say render component to string, and you get a string of HTML, and you send that down to the browser, and your browser, the first load experience in your single page application or whatever it is you're writing is really fast because the server's rendered that page for you. And then you might want to have some client-side routes and carry on client-side for a bit, and then you will press refresh, and the server will, the same components are running on the server that you've written, so you don't have to write your application twice. Same components running on the server, render component to string, generate a new string of HTML down to the browser, and that's the state of the application for that page. So it actually doesn't matter whether the server renders the page or whether the client renders the page, it's exactly the same, which is brilliant for SEO, for fast startup. You get non-JavaScript for free, so if you literally turn, in a React application, if you turn in an isomorphic React application, if you turn JavaScript off, you can carry on the same user experience. Obviously you've got a round trip each time, but same thing. So this, in the top of the string there's a checksum, and when that HTML gets to the client, you then call the client-side version of render component, which is just render component, and then inject the same stuff into the DOM again, and which it doesn't actually do, because what it does is it creates another virtual DOM and does a checksum on that, and if the two checksums are exactly the same, then it doesn't do anything at all. It just attaches the event handlers and carries on. But if the checksums are different, it will actually make the modifications that it needs to make it right. But it will give you a big error, a big warning in the browser console that says that you probably didn't intend this because the server rendered one thing, and now we're rendering something different. Am I running out of time? No. Okay, cool. But the great thing is that you can refresh any route, like I was just talking about. So any client-side routes, you press refresh and the server will render it for you. So you get non-JavaScript for free and fast startup for single-page applications. So if you deep link into any single-page application that's written this way, it will start. You get that page. Server renders that page for you, and you don't need Phantom.js or whatever on the server to instantiate your SPA for you, so that Google can index the page. So for anybody that does Node, this is like a little Express view engine that I put together, which is just nothing to it really, but it basically requires the view, which is actually a React component, and it calls render component to string. So it instantiates a new instance of that component, passes it the props that we were talking about, which are on the local. So you think of this as like, say it was a, I don't know, Jade view or whatever. These locals, which would normally be passed into the template, are actually passed into the component instead, and they become the data for the component. And you just render that basically into this locals.content, and you have just one template which just injects that HTML into that the placeholder in the template. That's it. Server side, and an example of how you might use this in an Express route. So this, I don't know where this is from, part of the application that we're building at the moment. So getting products with this ID, passing some context in so that we know we can authenticate with our API, and then that's going to return a promise of a body and a status, which we're not using the status, but the body become the props for this React component. So it's very similar to how you would use templates in Express or whatever. So because we've got this view engine plugged in, res.render will just pass that into there and then create the HTML, pass it down to the client. Right, so I can't do this without talking about immutable data for just 1 second, because I think this is where the future of React is probably going to need to go, or going to go to. Dave Nolan wrote OM, which is a wrapper around React that is written in ClojureScript. And because ClojureScript is, all the data is immutable by default, there's some amazing things happen, because from a performance perspective, I've got one more slide about that, which is quite interesting. But he stripped out all the immutable data structures from ClojureScript and created Mori, which is like a mini ClojureScript but for a JavaScript world, but it's still quite heavy. And then Facebook came out with immutable.js a month or two ago, which does a similar sort of thing, but it's a bit lighter, sort of 10K gzipped or whatever. But it turns out that if you can make certain guarantees to your React components that the data you're going to send into them is immutable, then it can make all sorts of like incredible optimizations about how it renders that data. So so wrapped by David Nolan. Immutable data structures, they have structural sharing and stuff, so it's actually really efficient. So basically what a persistent data structure or immutable data structure is that every time the data changes, instead of actually changing it in place, you would get a new copy of the object that looks like a complete brand new copy of the whole model, your whole data model, whatever. Underneath the covers, it uses structural sharing, so it's actually not creating a brand new copy. It's not actually doing any copying at all. It's just all pointers to arrays and stuff. So it's quite really efficient, really fast. But it looks to you like it's a brand new copy, so it's a different instance to the instance you gave it. And you changed it in such and such a way and you got a brand new one out. And if you pass immutable data structures into the top of a React component, then, or React hierarchy, then it can look at your data model and it can say, well, actually, this instance is exactly the same. There's a reference equals. It's exactly the same as that one, so I don't have to do anything. I know it hasn't changed, so I don't have to re-render anything. I don't have to redraw. I don't have to recreate anything. And so you can, from should component update, you can return false from that, which says don't do anything. You can leave this part of the tree untouched, because if I've got the same instance, it can't have changed because it's immutable. If I've got a different instance, then it probably has changed, or something underneath me has changed. So I need to go at least one more level down and see which of those are equal and which ones aren't. And it turns out to be a really, really fast way. So fast you can do it in request animation frame. You can re-render your whole application in the 16 milliseconds you get. So who's using React? Not many people. Facebook, obviously. GitHub are starting to use it quite a lot. So the Atom editor is written in React now, or at least the editor part of it is. Circle CI that Jamie mentioned to me today, which is written in OM, and Goya, which is also written in OM, is actually quite amazing. I might just jump in and have a look at that, because this is quite stunning. This is a pixel editor, which is pretty boring, and I've borrowed all this stuff from various talks, but in the left-hand, I don't know if you can see down here, it's a little preview pane and stuff. So I put some hair on him, and on the right-hand side, I'm getting, so I can go back to, oh, is it not working? What have we done? Oh, that was the history, yeah, so under, oh, typical demo, hey? I'm going to refresh that. Start again. Yeah, so it's creating a history down the right-hand side. Not a very good drawer, am I? Don't know what's happened. Really good demo that didn't work. Never mind. Really embarrassing that. Watch the video that that Dave Nolan on YouTube. Just it's actually quite amazing, and it worked for me last time. Maybe there's a new version of Chrome or something's gone. Anyway, yeah. So that's React. Any questions? Oh, maybe it might be worth maybe there is a demo of, like, Facebook obviously is written with React, and so is Instagram and stuff, but there's a really good React thing here that you can use to so these are React components, and then you can see for this particular instance all the data that was passed into it, and you know, all the particular data that's on this instance. There's also a get DOM node as well, so you can actually jump out and get the real DOM node if you want to do fancy animations or whatever you want. So, yeah, that's it.
Keep it up.
Cool. Any questions?
Can we see some of the things that you've built?
Yeah, you can actually. Actually, you can. So I can't. We're building a big application for a big grocery retailer, which I can't talk about until it goes live in 2 weeks, 3 weeks time, and then everybody can see it. So yeah, probably not this React meetup, but the one after that we're going to demo all that. But we did build help.sky.com with React. Now, so the team we've got at Sky, I'm not on that team, so I don't know anything about this application, and I'll be the worst person to demo it. But it is responsive. So, but these are all React components. So if I so it's actually quite interesting in the sense that they're actually different components, but because the state of it, as it changes from one to another, the state is preserved, even though the whole component has been swapped out for something else, because it's just reflecting the same model. But if I go into, that wasn't what I wanted to do. That was what I wanted to do. If you go into the React tab, so can anyone see this? Is it too small?
Yeah,
Sorry about that. Right, so we need to. So there's an index page with a tags control in it. So very similar to web components in the sense that you get this special. I've probably gone a bit big there. Maybe smaller. Which you can see the different parts of the application. So this has got a topic group small, but if I went wider, probably it would become topic group large or something. It would probably just switch out. I should go smaller. Uh-oh. I know. Maybe I didn't write this, but our team at Sky did. As you can see. So there's a mixture of what looks like HTML5 and what looks like custom components. And then if you selected one of these, then this has got a bit of state in it. Is selected as true. Hasn't got many props. I would have written that differently. I had more props in less state because state's bad. But yeah, that's one thing we built. I want to show you the other thing, but I can't. I'll do that next time.
So is it true that the virtual DOM is better than the shadow DOM?
Yeah, I mean, well, I don't know.
It was a joke.
I know, but it's an interesting question, and it's a question that's going to be asked a lot, I think, over the next year or so, because as web components come to maturity, which they will do. I mean, they're always going to be, because they're quite integrated in, like Pete said in his quote, because they're quite integrated into the browser. They've got to wait for the browser to, all the browsers to support them and all the old browsers to die off and blah blah blah. This is any browser going back and just lays over the top. You don't have to worry about. So theoretically, you can use it more now, I think, probably, and across more browsers. I don't know. I think the key thing is that components are brilliant for reuse and building applications. So that's the way to do it. Any other questions?
Do you just use React, or do you and obviously Closure and OM and stuff, so you don't really have M or C at all?
No.
You just have this whole structure. And I guess, how would you see it working with? How would you actually make it work in because people say it could be the V and M, but I see how you use it, but now I'm not quite sure how you'd use it with them. But how would you think you'd go about doing that?
So the Flux thing, if Facebook say it's not, there's no software associated with Flux, it's just a pattern. Right? It's not strictly true because there are examples and you can steal code from them, but it's not it's just a way of. So that kind of talks a little bit more about the rest of your application, how data flows through it. But it doesn't really answer anything about how you structure your data or how your models or how you get data from the server or it doesn't say anything about client-side routes or anything. So we build our applications just little bits of everything from all over the place.
Kind of mashed up, sort of.
Yeah, exactly. So I don't know. I mean, I can probably. I can't show the application running, but I can probably go into. So those. Oh no, it's just the guilt part. Those are the dependencies. Oh, those are dependencies, and so that there's all sorts of different things that we use from all over the place, and we just throw them all in. And React is just one of them. 0.11.1. So it's just one in a long list, and just push it.
And you do it mostly server-side rendered, so rather than client-side stuff, so kind of with Express and Node and things.
So both. So every single component runs the same on the client as it does on the server. So the server renders it to a string, send that string to the client. We also send with that all the data that it needs client side to render again, and that's the key thing, because when the component renders on the client, it has to have access to exactly the same environment effectively that when it rendered on the server, because otherwise it won't produce the same output.
Yeah.
So if we had inline scripting, we can't, because of the content security policy doesn't allow it, but if, we basically just put all the data into data attributes on the document element, and then on the client side it just pulls that out. It's just a bunch of JSON basically pulls it out and re-renders using the same data, and produces the same checksum, and if it does, it can carry on.
One more quick question and then we'll answer stuff. Okay.
How does the client communicate to the server? Does it use socket or something?
Yeah, so I mean, what do we use? We use Super Agent mostly, or yeah, client side we use Super Agent. Server side sometimes there's Super Agent down there. Sometimes request, but yeah, there's no jQuery in there, and it's all browserified up and packaged up and sent up.
Okay, cool. Have a
Awesome.
weekend.
Thank you.